Welcome to Tree U. We're on Module 11. We're going to talk about tree risk management and tree risk assessment when it comes to trees in the built environment. Now, tree risk assessment by definition is a systematic process used to identify, analyze, and evaluate tree risk. From a more professional position, it would be to quantify it as a product of the likelihood of failure and the consequences of failure. And we're going to talk a little bit about that in more detail during this presentation. So just plainly speaking, tree risk assessment is trying to determine what's the likelihood that that tree is going to fail and how bad are things going to be when it does happen. And that's what risk is all about, is basically assessing consequences of any action or any reaction. And it's a relatively new subject when it comes to arboriculture and tree care practices, with only about 30 years of research available to us. So we're still learning much about the tree and the biomechanics of trees under various types of loading and their defects. But new research is occurring every year to help us determine the likelihood of failure of trees, which is what we struggle with most. So risk trees are basically any tree that presents some type of safety issue at or where people live. Trees provide us significant benefits, but they do provide some risk as well. Now, one thing to remember is that all trees will fail at some time. It's just, is it predictable and preventable? Most likely, yes. But it's also important to remember too that in my opinion, we've become a little oversensitized to risk, and we need to make sure that we are able to weigh consistently the benefits versus the risk when we're making mitigation decisions and evaluations of the level of risk. So we want to make sure that we have an even playing field. When we look at a tree, we not only want to look at what's wrong with it, but we also want to try to find what's right with it as well and try to preserve that tree as best we can. Of course, there are standards that go along with this, as with every single practice that we've talked about that come from the ANSI A300. This is the BMP number 9, part 9, and this is basically applicable to all tree care professionals. And I think this is especially important for the climbing arborist as well. Remember when we talked about tree worker safety, that all-important tie-in point has to do with the reliability and the integrity of that tie-in point or that branch that you're attached to, because that's probably the weakest point in your entire system. So being able to positively identify any risk situations in the canopy is really important for your safety. The failure analysis of trees is the challenging part, but there is a biomechanical explanation for virtually every tree failure. It's really just the natural price for a tree trying to achieve this energy-saving, lightweight structure that the trees work so hard to maintain. And they're typically caused by external factors. Usually it's a combination of several factors that cause the tree to fail. They just don't fail randomly. It's usually, trees just don't fail at random. Typically it's a combination of several factors that often cause the failure itself. Usually it's a combination of things that include a defect and then some external stimuli, such as pest activity, external loading. We talk about wind or ice or snow, an uneven distribution of loads, perhaps from a asymmetrical canopy, structural faults, which includes codominant stems or poor branch attachments, and then of course some type of physical damage, which could be decay as a result of a car hitting it and causing a defect there as far as a wound. But again, it's a combination of factors that typically cause a tree to fail. Key thing to remember too is and we'll get into this a little more when we start talking about identifying defects. Trees always fail at their weakest point. So our goal whenever we're doing a tree assessment is trying to find those conditions of concern and the defect which causes that weakness where the tree is most likely to fail. So a few definitions that's really crucial to understand as far as tree risk assessment goes. And again, these are outlined in your study guide very carefully. In order to have a risk tree situation, you got to have a target. And a target is simply people, property, or activities that could be injured, damaged, or disrupted by a tree failure. Risk. Now we've talked about hazard trees before, and you may have heard that term hazard, but we want to talk about risk when we're talking about the assessment process. Risk is a combination of the likelihood of an event and the severity of the potential consequences. So remember I said, when it comes down to it, it's really about what's the chances of that happening and how bad is it going to be. So that's really what risk management is all about. And that when we use that term hazard, as I mentioned earlier, we've changed our dialogue and our definitions because hazard implies that there is already a likely source of harm there. And it kind of predisposes or biases your perspective, because when you hear something as hazardous versus something that is risky, it gives a little more of an elevated alarm or sensitivity to the situation. So we don't use hazard when it comes to tree risk assessment. We try to maintain the dialogue with using that term risk. Targets, we're going to kind of spend a little time on that as far as what they are. So what we want to think about is the frequency of that people or property or activity in the area of potential failure. So targets can be static, which means they're still or stationary, such as a home or an outbuilding or a deck. Movable means it could be like a picnic table or a swing set. And mobile, obviously, we would assume like a car or people walking, things like that. And when we're assessing identifying targets, we'll assess their value as well, and that plays a part in the tree risk assessment overall process. And so what we want to do is just also estimate the potential consequences of that failure. For example, this would be the target would be not the trail, but actually the people on the trail. But what we're saying when we put trails in like this is that this is where we want you to be. And so it's important for the property manager or the arborist or the tree risk manager to identify those areas and conduct inspections more frequently in those active use areas. Same with a shelter house. So in this situation, the shelter house, which is an expensive piece of construction, could be a target, but also the people in and around the shelter house and the playground would be considered targets as well. So that goes into the analysis process, is determining the targets and also the frequency. So how often are people in that shelter house, or how often are people on this trail in this park area? And also like this bench, how often are people sitting on this bench? The bench could be a target because it does have some value, but more importantly, people are the important target to consider in these situations. Now, for example, this car, obviously, streets become targets, but it's not necessarily the street that's the issue, because a tree can fall on a street without much other than incidental damage, but people walking down the sidewalk or cars parked or moving along the street are obviously going to be high value targets to consider in the process. So what we want to do is investigate target zones. So this is a great picture that shows several different targets. So this is a very large oak tree on a campus, and you can see that the target zone would be extremely large because of the size and impact of this tree. but what we want to do is try to identify targets. So take a minute to kind of look at the image and see what you can identify. So what I see in this is obviously there's a person there, buildings, sidewalks. So the sidewalks would not be the target, but people walking on the sidewalks. We want to think about how frequently do they walk on that sidewalk. There's also a parking lot here. Now, how do we assess what the target zone is and how big an area does it cover? Well, this is a very specific process. What we do is we take the height of the tree and we determine that either with some type of instrument or measuring device, and then what we'll do is we'll lay that down and determine the target zone based on the height of the tree. So if this tree is 50 feet tall, then we would lay this tree down and it would be 50 feet all the way around the tree would be the target zone. So anything that falls within that 50 feet or the area that's designated as a target zone could be a potential target. So that's what we look for when we're doing our assessment for targets, is what falls in that target zone. Everything that we identify and collect as data in the tree risk assessment process is placed on the ISA Basic Tree Assessment Form. All the data collected in the tree risk assessment process is collected on forms in order to get a risk rating system. There are various methods available to us. There's not any more right or accurate than others, but there are some that are more acceptable internationally and much more acceptable because of the BMPs and the standards. So they can be either qualitative or quantitative. The ISA uses a tree risk assessment that's target-based and qualitative, and this is an example of the form that they use for collecting the data. Now, there can be many different types of tree risk assessment systems. They just need to make sure that they're consistent and that they apply to your situation and that they fit the client's needs. So there's not necessarily a right one or a wrong one. Just make sure that you have the correct system for your scenario or situation. We'll go through the tree assessment process, talking about what we call the visual tree assessment. This is basically just reading the body language of the tree. So what we want to look at is start with the crown and just kind of work your way down. What we want to do is look to see, are there any conditions of concern in the crown or the canopy? Look at the stem and the trunk, and then also think about what the root system looks like. So we're identifying, for example, in this large maple tree, what are the defects? What are the conditions of concern? So we're going to try to find if there's any broken branches, things like that, crossing branches, poor attachments, cracks, things like that. So what we're going to do is identify those defects through assessment. We're going to analyze that data that we've collected, and then we're going to evaluate that data to determine our risk rating. So just a quick look at the various levels of assessment, and this will be important for you for your examination, mainly to identify which level of assessment to apply to which situation. So level 1 assessments are typically conducted on populations of trees, and this is what we call kind of our quick look for the obvious. This is typically used like after a storm. If, the urban forester might drive a certain area that may be affected by the storm and look to see if there's another tree that may need a level 2 assessment or a further look to determine its level of risk. They're one-dimensional, usually drive-by, or they can be flyovers in the application of vegetation management for utilities, or they can be walking down the sidewalk and just with a clipboard and assessing the tree very quickly for those imminent likelihoods of failure. So that's level 1. That's what I call the quick look. Level 2 is what we call the basic assessment level. And this is kind of the 360 ground-based look at the tree. So we're going to look in more detail at the root system and the root plate, the trunk, and the canopy and crown. really identifying what those conditions of concerns are and any types of defect that may have an impact on the likelihood of failure. So we'll look, determine if there's any lean, look for overextended branches, we'll look at branch structure and branch attachment. We'll also try to identify if there's any decay or positive indicators or potential indicators of decay, and look for things that, again, could pose a risk or increased likelihood of failure for the targets in and around that tree. For example, we'll take kind of a sample tree here. So what we would do is look at the crown on this particular tree to see if there's any poor branching habits, like there's a codominant here, dead branches up in the canopy, just not good branch attachments because of that. Again, branch aspect ratio is not real favorable. Then we'll, for example, we'll look at this stem to see if there's any cavities. We found one here that was looked like an old pruning wound that had not healed well. And then we'll go down and look at the root system, basically focusing under the drip line of the tree when we're assessing the tree. Now, when we're assessing for targets and target value, again, we'll take the height of the tree, lay that tree down, draw a circle, and look for everything in there that could be a potential target. But now we're just looking at the root system, and what we might be looking for is some compaction, or perhaps some fruiting bodies or mushrooms, or see if there's any cut or damaged roots, so those types of things. And also examining the root collar to see if there's a root flare, or has it been planted excessively deep, or perhaps some fill added to it, or even damage from excavation. So visual tree assessment is reading the body language of the tree. It's a systematic from the roots to the trunk to the canopy. So the first thing we'll look at is the root system to see if there's any fruiting bodies, mushrooms, or anything like that, or perhaps a heaved root system, perhaps some roots showing due to wind throw. The next thing we might want to look at is the trunk to see if there's any decay. Now, there's obviously some decay pockets here, which could increase the likelihood of failure. We also see some carpentry ants in here, which is a good indicator of decay as well. So those are good forensic buddies to kind of help us with that system. Now, as we move on up the trunk, we want to look at the branch connections to see if there's any codominant stems or included bark. Here we see kind of a codominance here and some included bark with decay, so that has a higher likelihood of failure as well. Here's another good example of a codominant stem. Branch aspect ratio is 1:1. We have included bark, and you can see it through here. So this has a really high likelihood of failure in the event of wind loading. So those are just some of a few things we want to look at during the visual tree assessment. Now, in advanced testing, this is usually something that is a request after level 2 if additional information is required or the client dictates that. It's usually specific parts of the tree or defects or conditions in the tree that we're looking at. Advanced testing or level 3 assessments often involve specialized equipment and procedures. For example, it may require an aerial inspection to look at a specific area of concern or a defect, or point testing, which is the use of an increment bore or a resistance drill, or it could be root excavation to take a look at the root system to see if there's any decay or perhaps root collar damage. It's important to make sure you're able to effectively use this equipment and interpret its results accurately. This is typically defined in the scope of work and usually the recommendation of the arborist, but it must be accepted and agreed upon by the tree owner or the client. Let's take a look at some of the more common defects that we typically see when it comes to risk trees and some conditions of concerns. Obviously, we can't cover them all because there's so many different situations and scenarios, but let's look at some of the more common ones and what we might be able to do with those. So first of all, the types of risks that we typically run into are either conflicts or structural failures. So conflicts can occur just with sidewalk heaving, which creates a risk situation. Or it could be utility pruning, which may predispose or elevate that level of risk due to the pruning activity. It could be improperly installed trees that are affected by, for example, this planting grate, where it's actually into the tree and perhaps destroying the stability of that trunk. It could be as simple as thorns on a tree that present a risk to passing by pedestrians. With structural failures, we either talk about whole tree failures or failure in part. So it could be just a branch failure, or it could be a large major stem failing, or it could be whole tree failure as well. So, and right down to the root system where we have wind throw due to a poor root system. So all of these things are typical types of failure that we'll see in the built environment. First thing we want to consider is site factors. Remember I said it's a combination of factors that typically cause the failure. It's not just a defect, because everything has a defect. Every single living organism has some type of defect in it. It's when the right factors, external stimulus or factor that emphasizes that defect that causes the failure. So we want to look at previous damage, wind exposure. Has there been any modifications around the site? We'll look at soil hydrology to see if it remains wet for an extended period of time with like saturated soils, or maybe sandy soils with poor root holding capacity. So all of those things will play a part in identification of potential for failure. So these are some examples of some structural effects. These are some examples of some structural defects that commonly affect the likelihood of failure. And there could be a lot of different things from cracks and splits. As you can see, I've got my surveying pin in here measuring the depth of that crack. Codominant stems, which is poor architecture, looking for decay pockets, wounds, included bark, any type of disease or signs of disease that may increase that likelihood of failure. When we're talking about decay, which is one of the most important conditions of concern affecting likelihood of failure, you want to make sure you understand the difference between potential and positive indicators. This will be on your examination. So what we want to look for as far as potential indicators are things that could be potential decay, reveal potential decay, but may not necessarily be. But again, it's an indicator that it could be there. So what we want to look for is old pruning wounds to see how they've recovered or compartmentalized, decayed stubs, any physical wounds, for example, from lightning damage, any seams or cracks. I also look for adaptive growth or swelling on the trunk. You know, we see that normal taper on a tree. Is there any anomalies or atypical sections of the tree where you can't really see anything, but you know it's not quite right? Or trunk flattening, or even what we call bottle bud at the root flare, or trunk swelling at the base. So those are potential indicators that something could be wrong, but we aren't actually seeing the physical signs of that decay. Now, as with trunk damage, oftentimes it starts with a wound, and it may or may not develop reactive tissue. So oftentimes this callus tissue will form in an attempt to prevent further decay, but we want to look for that threshold depending upon the size of the tree. About if more than 30% of the circumference of that tree is decayed or damaged, then it warrants further testing and investigation. This is the response growth I was talking about. Again, important terminology to know for the examination, so make sure you really read this over very well in the study guide. Response growth is really just the production of new wood in response to some type of wounding. And it comes in three forms: reaction wood, flexure wood, and wound wood. So reaction wood includes tension and compression wood. And this is just basically a buildup of fiber depending upon how the tree moves. So for example, if I stood up and if I'm a tree standing, so if I lean forward, then my stomach or abdomen is under compression, and then my back is under tension. So in a leaning tree, we would look to see what the conditions are of the compression wood and the tension wood in our assessment process. So if there's an increase of wood fiber on the tension side of a leaning tree, that's a good thing, because that means it's compensating for that lean. And we'd also look for any buckling or issues in the compression wood, like cracking, to see if there's some type of potential failure there. Now, as far as flexure wood, that's sort of the difference between a tree standing still and a tree moving. So if a tree's moving, like normal wind conditions, and just kind of swaying in the breeze, what that tree's doing is building fiber. And just like us, it's working out. When we work out, we build fiber, muscle fiber. When a tree moves, it's building additional wood fiber in response to that loading. And so a tree that continually moves and sways is continually building fiber. That's why we see open grown trees with the larger root flare and buttress roots. Now, when we look at trees in nature, they're often very slender with very little taper. That's because they're restricted and can't move. And so those are good things to look for, and that's a positive response to its environment that will reduce the likelihood of failure. Wound wood is what you see here. And remember, we talked about wound wood when it came to the compartmentalization process. Wound wood, if you'll recall, and you'll need to know, is wall 4, and it's the reaction zone that creates new tissue. And this is a positive response. This is highly lignified wood with some decay-resistant phytochemicals that helps to improve that tree's ability to occlude that wound. So that response growth is always a positive thing. That's one of those things I mentioned earlier. When we want to look for what's wrong with the tree, but we also want to look for what's right with the tree as well. And response growth is one of those positive things that can make a difference in that determination of likelihood of failure. We have potential indicators, which means there's a potential for decay. Now, we also want to see if there's any positive indicators of decay. Now, this is sort of like the difference with symptom and sign, if you will, if you want to kind of compare those two. Positive indicator is a sign. So that's actually sign of the decay. So whether it's a bleeding canker or some type of, this is Trametes, which is a sap rot. We'll also see this bulging and swelling here that actually shows some decay on the other side. And then also the presence of carpenter ants and the frass will actually indicate that there is decay, because carpenter ants don't attack living wood. They only colonize dead wood. This is Latoporus, and you can see that it's the actual fungal fruiting body growing on the side of the tree there. So those are positive indicators. That means there's definitely decay there, and we need to examine that a little closer. So there are different types of rots associated with decay. First, we're going to cover white rots, which have specific characteristics that affect the likelihood of failure. First of all, and again, make sure you know these bullet points or highlights that I think they're important for you to remember for the examination process. There's a little more detail in your book or study guide about these, but these are some definitely good ones to remember. White rots typically attack the lignin first. Lignin is an important wood fiber. There's lignin and cellulose. Lignin is the part of the wood fiber that gives trees flexibility. So bending, it allows the trees to bend without failing. So, and remember, as I demonstrated, bending can actually stimulate response wood. So white rot may have a reduced likelihood of failure as opposed to other types of rot organisms. So with white rots, the effective wood loses its strength, but maintains some flexibility. So those are some key items to remember for your examination. Now, brown rots are typically kind of blocky cubical rots that are characterized by attacking the cellulose first, which is the kind of the string or the rebar in the tree, and so the tree's unable to bend or loses its bending strength. As a result of that movement, the tree's more likely to buckle or fail with brown rots. So those are two distinguishing characteristics. White rots primarily attack the lignin first. Brown rots typically attack the cellulose first, which causes a loss of bending strength. Heart rots are pretty easily identified because this is what's associated with a hollow tree and causes decay in the heartwood or center of the tree. There's a lot of things that go into this, which we won't cover, but is definitely covered in tree risk assessment. But what's important to understand is that heart rots are not necessarily elevated risk, but the extent, the amount of heart rot and decay and the location within this cross-sectional area makes the biggest difference in likelihood of failure. Again, not a lot to say about this other than this is what's associated with heartwood rot and hollow trees. Sap rots are what attacks the outer from the outside in. Most of our other rots work from the inside out. Sap rots often invade healthy wood, and I think they're of extreme or critical importance, especially to climbing arborists and in the rigging process, because they attack the sapwood. And the strength of the tree is typically on the outer portions of that branch or stem or trunk. So it attacks the cambial layer, which reduces the stem strength tremendously. So make sure you're able to identify that, again, especially if you're a climber. Basal rot is typically some type of canker that increases the likelihood of failure for the whole tree failure, and it typically progresses from the roots into the trunk. So that's the key thing to remember there. Root rots, oftentimes we have just a decay in the roots due to some type of injury or damage, and we'll see the actual fruiting bodies typically, like this armillaria. But this can infect the integrity of the roots and increase the chance of wind throw. So when you see a lot of fruiting bodies around the root plate, that's a big indicator that you got some problems there with poor holding capacity for that root system. Other root problems include physical damage. We looked at this during the construction and tree preservation module. Of course, compaction, all those things will affect the tree's roots, which also increases the likelihood of failure as well. Now, what do we do if we have some type of risk? We've identified it, obviously we've analyzed it, and now we're going to evaluate the actual risk rating. And depending upon the risk rating will help dictate what type of mitigation. So, and remember, also important, these are definitely in a strategic order, and I'll explain that. So first of all, remember, this is a target-based assessment system. So if we can move or remove the target or limit access, then we've helped mitigate the risk there. If we can prune the tree, if it's a broken branch or perhaps a defective branch, if we can prune it out, then we've mitigated the risk. We may need to install structural supports, as we discussed in a previous module, such as cabling and bracing, to help lower the risk of failure. Or we may need to modify the site or conditions on the site to help improve drainage, to prevent extended soil saturation. These are all, again, there's target-based and tree-based type of mitigation. And the last and certainly least is removing the tree. That is a last-ditch effort to try to mitigate risk, and all of this is dependent upon the client. The job of the arborist is to present the mitigation options, but it's up to the tree owner or tree manager to determine how they're going to mitigate that risk and when. So everybody has a different acceptable level of risk. For example, it may be perfectly acceptable for you to jump out of an airplane with a parachute, where I think that's absolutely unacceptable risk. But again, some people may be able to accept the level of risk with a dead tree in their lawn or their landscape until it falls, and where some people can't afford that level of risk and say, oh my gosh, that tree's dead, that could fall on a tree, on a house or a car or somebody walking by, we need to get that down immediately. So acceptable level of risk varies. Oftentimes it's driven by not just safety, but also budget in municipalities. Also, the significance of the tree is going to dictate mitigation. It may determine whether or not the tree can or cannot be removed without a lot of special considerations. Also, how does it affect aesthetics? Some more definitions. Tree risk assessment has a lot of definitions in it and concepts that are important for you, especially for passing this exam. Some key things to remember. There's duty of care and standard of care. Now, you can listen to me talk about this and kind of explain it in terms that I understand, but I highly urge you to make sure you review the study guide from ISA to kind of just keep reading it and getting a grasp of it. But basically what it says is duty of care is that everyone has a legal obligation to apply reasonable actions to prevent potential harm to others. So we all have a duty of care, even within our own homes. We have a duty of care to keep our property safe so that others that are in or around our home are not injured. Well, it's also a responsibility of the tree owner to ensure a level of safety for people, properties, and activity around those trees as well. For tree risk assessors, we're responsible or have a duty of care to apply relevant standards through the assessment and inspection process. So everybody has a shared duty of care in tree risk management. So for example, tree owners, if I park my car under a tree at a friend's house and a branch falls, goes through my window, what the legal system's going to try to determine is, was a reasonable duty of care exercise to keep that tree safe. So again, everybody has a duty of care in some form or fashion. It's not up to us to decide, it's up to the legal system to decide if it was reasonable in that particular situation. Standard of care is the degree of care that a reasonable person would exercise in performing duty of care. Now that gets a little bit complicated and confusing, but that means when you're exercising your duty of care, is it a reasonable standard of care or level? So when I'm doing an inspection, for example, or a tree risk assessment, am I exercising reasonable standard of care in that process? The duty of care isn't the inspection. How I conduct that inspection is the standard of care. So again, it gets a little complicated. Again, I'm not an attorney and I don't play one on TV. When you do tree risk assessments and involved in tree risk management, it's important to understand some of the concepts and legalese when it comes to that process. So reasonable care is defined by proper application of the best management practices. Standard of care means qualifications and continuing education and your credentials. Standard of care means, are you actually qualified to actually do a tree risk assessment? So those are important considerations. When you're asked, is my tree safe? That's a very big question and could be a very expensive response. So kind of finishing up this module, some risk mitigation responsibilities, very important to remember. The tree risk assessor recommends the risk and they're responsible for communicating it to the tree owner or client. It's up to the client to decide what to do with those options. So you're the messenger, it's up to them to decide what they do with that message. Also, it's important to indicate a time frame for mitigation options. So if this tree has a dead limb in it that needs to, or has a risk of high risk of failure, then you need to communicate with the tree owner that this is a condition of concern that has a high level of risk and should be removed immediately. Or perhaps you find a tree branch that is declining and you know it's not going to recover. So what you might communicate to the tree owner or manager is that this tree branch presents a moderate risk of failure and should be pruned and removed within the next few weeks. So again, give them a time frame because they're not arborists and they're looking for you for your professional opinion based on your assessment. But again, so very important here, this last statement. The tree owner and the tree manager is ultimately responsible for choosing the mitigation action and when it will be performed. I'm guarantee you're going to see or hear that again. So make sure you remember those concepts here when you're reviewing and preparing for the test. Okay, so this wraps up our tree risk assessment and tree risk management module. Make sure you coordinate this instruction with a study guide so you are able to coordinate all your resources and be successful in the passing of your Certified Arborist exam. Well, we want to thank you for participating in the TreeU Certified Arborist Preparation course. We hope that it's been a great learning opportunity for you. If you're watching these videos to obtain continuing education units, be sure to